In this video, we are going to look at logarithmic equations and how to solve them. First, let's go over the equivalence property, but for logarithms. If you have log base b of x is equal to log base b of y, notice that the bases are exactly the same, and it has to be exactly the same for this property to work. So then we can claim that the input x is equal to the input y. Let's do some examples. Example 3, part A. Log base 2 of 3x minus 4 is equal to log base 2 of x plus 2. So because the bases are exactly the same, they're both 2, I can claim that 3x minus 4 must equals x plus 2. This is a linear equation which can easily be solved. So subtract x from both sides. So you have 2x minus 4 is equal to 2. Then you add 4 to both sides. So you have 2x is equal to 6. And then divide both sides by 2. You get x is equal to 3. Now, let's check our answer. To check, you substitute it back in the log equation. So we have log base 2 of 3 times 3 minus 4. And the other side, we have log base 2 of 3 plus 2. So on this side, that's log base 2 of 9 minus 4 is 5. And the other side, log base 2, 3 plus 2 also give you 5. So at the end, as you can see, the left side equals the right side. Example B. This time we have 3 logs. The natural log of x minus 4 equals the natural log of x plus 6 equals, or minus the natural log of x. So we can't use this equivalence property unless we have one single log on the left and one single log on the right. Right now we have 2 logs on the right and 1 log on the left. So I would like to merge these two as one single log, which we learned how to do that in the previous section. Then we can use the equivalence property. So ln x minus 4. Here I see a minus sign, so that means we should be able to use the quotient rule. So that's ln of x plus 6 over x. Now that the two logs have the same base e, we can set the input to equal each other. So x minus 4 is equal to x plus 6 over x. I can solve this by using cross multiplication. I can put x minus 4 as x minus 4 over 1 and do cross multiply. So when you do that, we have x times x minus 4 is equal to x plus 6. And then distribute, I have x squared minus 4x is equal to x plus 6. Looks like it's a quadratic equation. So we're going to move everything over. And we might see if we can use factoring or if we can use a quadratic formula. So this will give us minus 5x, and then move the 6 over 2. Let's see if we can factor. We want 2 numbers multiply to a times c, so that's negative 6, and add up to b, which is negative 5. Well, the 2 numbers should be negative 6 and 1. So we have x minus 6, x plus 1 is equal to 0. Solve each of these. We have x is equal to 6, or x plus 1, or x is equal to negative 1. Now, this is why checking your answer is super important. When you plug it in, one of the logs is not going to work. Simply because if you look at the condition for logs, the input for log, so x and y here, always has to be positive. And so if you were to substitute this x is equal to negative 1 in for this log, which is log of x here, then that's going to be invalid. So therefore, we can't accept that answer. And we will only accept x is equal to 6. So please always make sure that you check your answer at the end. Example 4. So we have 4 times log base 3 of 2t minus 7 is equal to 8. I want to point out here that there's only one log in this equation, which is different from the other two that we just did. We had 2 logs. So how do we deal with 1 log? We could use the definition. But first, let's isolate that log by dividing both sides by 4. So on this side, we have log base 3 of 2t minus 7 is equal to 2. So when there's only 1 log involved, you can go back to the definition of log and convert it to the exponential form. And use the arrow trick if you want to. So that's 3 squared is equal to 2t minus 7. So that's 9 is equal to 2t minus 7. We're going to add 7 to both sides. So that's 16 is equal to 2t. Divide both sides by 2. We get t is equal to 8. So let's check our answer. We have 4 times log base 3 of 2 times t is 8. Minus 7 is equal to 8. We'll put a question mark there. So that's 4 log base 3 of 16 minus 7 gives you 9. And then log base 3, 9 is the same as 3 squared. So this will cancel to simplify to 2. But we'll look at 4 times 2. And 4 times 2 does give you 8. So it is equal to the other side. So that means our answer is correct. Let's try another one. Again, 1 single log, and the log is already isolated in this case. So we're going to go use the definition to convert this to the exponential equation. So because nothing is written, we know that that's a base 10. We're looking at 10 to the 2.6 is equal to w plus 47. Don't be intimidated by 10 to the 2.6. That's just a constant. And if you want the exact answer, then don't use your calculator and try to calculate 10 to the 2.6. Just leave it that way. Subtract 47 from both sides. So w is equal to 10 to the 2.6 minus 47. This right here is the exact answer. And if you want the approximate answer, then use your calculator. This should give us 351.1072 if round to 4 decimal places. Next, we have this one. This one looks a little tricky. It's not exactly the type of equation we dealt with before where we have logs on each side. In fact, we have a log inside of a log. But the process is actually the same as what we've been doing. We can convert it to the exponential equation, and you can use the arrow trick here as well. So we're looking at 5 to the 1 is equal to log base 5 of x. And this is the same as log base 5 of x is equal to 5. I just switched the side. And we can apply the definition again, convert it to an exponential equation. So 5 to the 5th power is equal to x. So as you can see, we get x by itself. We just had to calculate 5 to the 5th power, and that will be 3,125. Example 5. Now we see multiple logs again. However, we can't use the equivalence properties due to the fact that it's not as straightforward as having one log equal to the other. We have another number involved. So in that case, we're going to follow these 4 steps. Step 1, isolate logarithms on one side. Right now, the logs, one is on each side. I want them to be on the same side. So I have log base 2 of x, and then move the other log over. It will become plus log base 2 of x minus 2. Now we're going to leave the constant 3 on the other side. Step 2, use properties of logarithms to write the equation in the form log base b of x is equal to k. So we want to write as a single log. So I see the plus sign here. That means I can use a product property. So that's log base 2 of x times x minus 2 is equal to 3. Step 3, write the equation in exponential form. So that's going to be 2 cubed is equal to x times x minus 2. So x times x minus 2 is equal to 3 or 2 cubed, or 8. Step 4, solve the equation from step 3, then check. So equation from step 3, we can distribute the x, so we have x squared minus 2x is equal to 8. Move 8 over. Let's see if we can factor this. So we want product of two numbers that we're looking for to be negative 8 and sum to be negative 2. So the two numbers should be negative 4 and 2. So that's going to be x minus 4, x plus 2 is equal to 0. So x is equal to 4 or x is equal to negative 2. Now looking at our original equation, I see there's an x here. If I were to substitute the x is equal to negative 2 in there, we're going to end up with log of a negative number, which is invalid. So we can't accept that answer. We would only accept x is equal to 4.